Okay, hello. Today I'm going to show you guys about graphing inequalities. It's chapter 6-5 in Algebra 1. And now this is an inequality, and we've already solved inequalities. We had a section on that earlier. There's a couple things with this. The first thing is it's nice to have it in y equals mx plus b, or y is greater than mx plus b. With this, it's the same thing that applies to, this equation. Most of it applies to the greater than or less than, all right? The only difference is going to be at the end when we shade one side of the line or the other. The other thing that is different is if you have one of these two symbols, like that one, if it's greater than or equal to or less than or equal to, that will be a solid line when I graph it. And if it's just less than or just greater than, that will be a dotted line. All right, and I'll show you what that looks like in just a few minutes, but that's the first thing I want to show you. So I'm going to graph this line, and I'm going to graph the boundary line. This is going to be a solid dot, or a solid line, excuse me, because it has that or equal to underneath it. If it didn't have that, then it would be a dashed line, and I'm going to show you what that looks like in the next problem. All right, so I'm going to graph it just like y equals 2x minus 1. That has a y-intercept of -1, which is here. That's where it crosses the y-axis. And it has a slope of 2. Now you can always make the slope into 2 over 1, which means, the rise is 2 and the run is 1. So I'm going to go up 2. This has positive slope, so it's up and to the right. If it was negative slope, I'd go up and to the left, or you can always go down also, but I usually go up just for whatever reason. All right, and let me get back to blue. So up to the right, up 2, and this is looking like my boundary line then. Zoom out a little bit, and put the line in there, and there it is. Okay, now, let me show you two ways to do this. The first one is I'm going to use what's called a test point, okay? And the test point is you can use any one you like. I love using 0, 0 because it's really easy to work with. So if I take the equation, the y, is greater than or equal to 2x minus 1, and I plug in 0, 0. 0 is y, and 0 is x. 2 times 0 is 0. 0 minus 1 is -1. So I get 0 is greater than or equal to -1. Now 0, 0 is there on the graph. That's the origin. And this is true. 0 is in fact greater than -1. 0 is greater than all negative numbers. Therefore, that side of the line is the solution side. If I got something that was false, then the other side of that line would be the solution side. So one side of this line is going to get shaded. Oops. And you can see I'm going to just go and shade that side of the line. And then you can see that any point on that side of the line is a solution to that inequality. All right. Now, like I had said, if it had been false, then I would have shaded the other side of the line, but it wasn't. So, all right, next one. Number 2. Do this one in red. Y minus x is greater than -3. Okay, now it's easier to graph this line if I get y all alone on one side of the inequality. So what I'm going to do is I'm going to move that x, okay? And the opposite of subtracting x is adding x. So that's what I'm going to do. I'm going to add x to both sides. And I get y is greater than or equal to -3 plus x or x plus -3. All right, either one. Now I'm going to graph that line. Now this is like this. Now, because it doesn't have that line underneath it, this is going to be a dotted line. Okay, now when I go and graph this, the y-intercept is -3, and the slope is what's in front of the x, and there's nothing there, so there's always an implied 1 there, so that would be 1 over 1, which means, and it goes in the positive direction, I'm going to go up 1, right 1, up 1, right 1, up 1, right 1. All right, and now I'm going to do a dashed line as best I can here. Oops, I'm off. And you can see the difference between the two graphs. Now I'm going to shade one side of that graph also. Once again, you can use any point you want. 1, 1 is a good point to use. That's easy numbers to work with. If you want to pick the number -27, -13, be my guest, but it's just tougher on the math. So if I use my test point of 0, 0, and I plug in 0 for y and 0 for x, I get 0 is greater than -3. Once again, that's true, so I'm going to shade this side of the line with the side where the test point is. If it wasn't true, I would shade the side where the test point isn't. Okay, now, when I was taking algebra as a young man, I did graph a whole lot of these, and I figured something out. And and I went and asked my teacher if it was always true. And what I said was, if I have something that's like this, y is greater than, I'm always shading above the line. And if I have something that's like this, where it's y is less than, I'm always shading below the line. And I said, does that always work? And my algebra teacher said, yeah, it does. As long as you've got y all alone on one side of the inequality, that always works. Now, it could have the line underneath it, in which case nothing changes. It'd be the same thing. So if it's one of those two, shade above the line. Really put that one next to it. Y is less than or equal to. So that also works. So if I went and looked at this graph over here, this problem, and I said y is greater than, you can see I would go over here and I'd be shading above this line, which is like this side of it, where it crosses the y-axis is really where the point you're looking at. But you can see that's above the line. That's the side we shade, and it's everything above that line, even though I didn't completely shade the graph. Okay? All right, so that's a nice shortcut for you. All right, next. Now, these are the hard ones that are, the easy ones that are hard. And this one is x is greater than -2. So if I ask you to graph that, you have to know what that line looks like. Now that's going to be either a horizontal or vertical line. It's going to end up being a vertical line because it goes through -2 on the x-axis. And since it's just x is greater than, it's going to be a dashed line, not a solid line. Change colors, that's not so good. It'll stick out better. So -2, vertical line. That's x is greater than -2. Now you're going to shade one side of the line. This one, you're not shading above or below it, but the numbers on the x-axis that are greater than -2 are over here, this direction. For example, 3 is greater than 2, so that would be you could plug that in if you want, 3 for x, and you get 3 is greater than -2. Yeah, it is. That's the side I shade. All right, so I'm going to shade that whole side of the line, and I'm done. All right. Okay. Why don't you try this one? Y is greater than or equal to -2x plus -1. All right, go ahead. You try it on the graph paper and come back Okay, welcome back. So I'm going to start at -1 on the y-axis. Slope of -2, which is up 2 left 1, up 2 left 1, up 2 left 1, so on, so on. Goes that way. All right, so there's the boundary line. This is a solid line because it's got the or equal to underneath it. And let's see, I'm going to do it the shortcut. This is y is greater than or equal to. So like up here, that would be y is greater than or equal to. So I'm going to shade above the line. And I'll change colors just so it looks a little different. It's above the line. And there it is. All right, so far so good. Okay, so I got 2 more problems. One, this is probably about as hard as they get, I think. This one, I had -2y, this is problem number 5. -2y plus 3x is greater than -4. All right, so for me to graph this, I want to have y alone, all right? Now, it's not the only way to do it, but it's the way I like to do it, which means I'd like to move that 3x. The opposite of adding 3x is subtracting 3x. So I subtract 3x from both sides. I get -2y is greater than, I'm going to put the 3x first, the -3x first. Either way is fine though. All right, now my next step is get rid of that -2. Now that's connected by multiplication. There's always multiplication implied there if there's nothing written between the variable and the number. So I'm going to divide everything by -2. Now, I know it's been a while, but when you divide an inequality by a negative number, you got to flip the sign, flip the arrow the other direction. Because you divide it by a negative. Anytime you multiply or divide both sides by a negative number, you got to flip that sign there. So now it's going to go that way, and then everything else stays the same, like I was, solving an equation. The y is alone. -3 divided by 2 is -3/2. -4 divided by -2 is +2, and that's the equation that I'm now going to go graph. Okay. All right, so I'm going to go over here. This is going to be a dashed line because it's got no line underneath it. It's just y is less than. I'm going to start at 2 on the y-axis. And this has a negative slope, so that's going to go this way. So I'm going to go up and to the left, up 3, left 2, ran out of space that way, so I can also go down 3, right 2. That's the other way, down 3. 2. Okay, I got enough points now. Now I can make my line. Make it nice and long. Put some arrowheads on it. All right, now you could do a test point if you want. If you plug in 0, 0, you'll get 0 is less than 2, which means that's the side of the line you shade. Or you can just look at it and go, gee, it's y is less than, therefore I'm going to be shading below the line. Okay, great. Now, my last problem, number 6, is determine whether the ordered pair is a solution to the linear inequality. Those are the directions. Determine whether solution to the inequality. Okay, and the equation is 7x plus 3y is greater than -6, and they give me the point. So that's the ordered pair, and that's the equation. So what I'm going to do is I'm going to plug the x, which is the -1, and the y is 1. I'm going to plug that in here and see what I get. And if it's true, that's yes, it's a solution. If it's no, it's not. And let's see, so if I take -1 and plug that in for x, and then I plug in 1 for y, the rest of this will stay the same. 7x plus 3y greater than -6. Okay, so 7 times negative 1 is negative 7. 3 times 1 is 3. Negative 7 plus 3 is negative 4. Now this is one of the tricky ones. Negative 4 is greater than negative 6. Remember, if it's out on my number line here, here's negative 6, here's negative 4, and over here is 0. Since it's to the right on the number line, this is greater, this is true. So yes, it's a solution. Okay, and that is the last problem I got for you today. I'll see you all soon.
But what can you do? I don't know how meant to act it all of you lot. Sometimes you don't try.